Hey there, Dr. A here, CEO and founder of the Learning Liaisons, and I got great news for you. Coming up in this video, you're going to get access and you're going to be able to watch our recently recorded live webinar for Math 6 through 12. This is for our peeps who have to take the Florida Teacher Certification exams, who have to do Math 6 through 12, our Praxis peeps as well, who have to take their Math 6 through 12 exam as well. So sit back, relax, grab your popcorn, and watch as our math director, Anderson Duran, leads the way in this webinar recording. And make sure you stay tuned to the end because we got a real surprise for you at the end. And also make sure you like, comment, and subscribe to this video as well as all of our videos here at the Learning Liaisons by clicking that button up on the top corner there, that subscribe button for the channel. So once again, I'm Dr. Ray here, CEO of the Learning Liaisons, and like we always tell our teachers and leaders here we work with, remember, it's when you pass your certification test, not if. Guys, have a great time, enjoy the video, and we'll be back.
So everybody, welcome to our 612 math little webinar here with the Learning Liaisons. It's 3 p.m. So this is away from our usual 7 late night webinars. So we're excited that you guys are here. We're excited that you're taking this seriously, even with all this going on in the world. We have a lot of good things coming to you in this webinar. So we're going to go ahead and dive right in. So with that said, I'm Anderson Duran. I am your math director here. I'll talk a little bit about myself in a bit, but first things first, we got to talk about a few things that are, that you need to know, because you're going to get access to this recording, and this is going to be available on our YouTube channel. So go ahead and let us know in the chat box. Are you subscribed to us on YouTube? Yes or no? Because you can probably find a lot of content that you can use just to yourself whenever you need it. So give me a yes or no if you are, because the thing is, I'm going to make it real easy for you to subscribe and get updates on everything that we do. That way, whenever you need it, it's right there for you. Yes, you can ask questions in this webinar. Yes, you absolutely can. That's the point of a webinar like this. We want to be exposing ourselves to you as the experts so that you can ask us questions and really build that confidence step by step, question by question. Next, this webinar is going to last for just about 75 to 90 minutes, so maybe an hour 15, an hour 30. I respect your time, so I will be done with this webinar before 4:30. All right, I will be done. I do respect your time. We have things to do, whatever that may be given the circumstance, but I do respect your time. Next, obviously, no, this webinar is not going to prepare you for this exam. I'm going to show you the competencies and skills in this test, and you're going to be like, yeah, you could probably run 20 webinars and we probably still couldn't get it all done. And I'm going to show you what you can use to really prepare the right way. Yep, we're very different from study guides. Study guides, if I'm being quite honest with you, they're the reason that everybody fails the first time around. And it's because these study guides have a really bad habit. And tell me right now in the chat box if this applies to you, if this is your life in any way, shape, or form. Have you ever had a study guide and for a test that you're getting nervous about, you kind of just go in there and you just try to memorize everything, memorize the questions, memorize the answers without actually diving deeper to understand why those answers are right or how those concepts work. And so you go ahead, you try to memorize everything. And then when you take a test, whether it be the 612 math or any other test you've taken, you just try to hope for the best and something that you've memorized is on there. Has that ever been you? Because that's been me before when I was studying early on. But as I grew, I learned that, hey, the concepts, they're more important. But I'm going to admit right now that, yeah, that's happened to me before. So in the chat box, has that ever happened to you where you gotten tricked into memorizing things, even though the right way to go about it was to learn it from the ground up? Yeah, and thanks for being honest. There you go, right? So Michelle, Gail, yeah, it's happened to everybody. It's happened to a lot of us at some point or another, depending on how tough it may seem. And so for the 612, it's more important now than ever that we really get to those basics, learning the alphabet of math to really build back up. And again, I've got your back on that in this session. So make sure you have your phone camera out and ready to go. If you have an Android or an iPhone, just have it ready sitting next to you, because here's what you're going to do. I want you to go ahead, grab your phone, open up the camera. Don't take a picture. Okay, I'm not trying to be on your phone here, but just go ahead, grab your phone, and just open up the camera. Because all I want you to do is point it at that little QR code right there. Because it's going to take you straight to our YouTube page so that you can subscribe nice and easy. And even so, even if you don't have a phone that works for this, or you're using your phone for this webinar, you can type in youtube.com/thelearningliaisons, and boom, you can find our page, subscribe nice and easy. Once you type it in, it takes you straight to the app, straight to your login. Boom, Bianca, that was easy, right? And it takes you right there so you can subscribe. That's where you're going to find this webinar's recording, all of the problems that we do here, in addition to all of the other webinars and videos that we've produced here. And trust me, it's a lot. So you're going to want to be in there. So cool. With that said, I'm going to leave this up for another 5 seconds. I'm going to fill this in with some words. If you couldn't tell, I've been having a good day. And we're moving on. Dr. A says he does calculus in his sleep. The numbers float through your head. Wow, that sounds interesting. I wonder why you have a math director. I wonder why you have a math director, Dr. A. So with that said, let's go ahead and dive right in. I want to go ahead and talk to you guys a little bit about who I am, because again, you know, calculus is tough. All the topics here are tough, and I know I look younger than I am. So with that said, I just want to introduce myself. I'm Anderson. If you haven't been to a webinar, I am the Director of Mathematics Learning and Development here at the Learning Liaisons, and I've been proudly serving in this capacity for about 2.5 years now, going on 3. And it's been awesome. You know, I've got my master's from UCF and my bachelor's in math education. And ever since then, I've just been helping people succeed, whether it's with the FTCE, the Praxis, the SAT, with AP Calculus that I taught for 2 years, the GRE, you know, whatever it is. I don't care what it is. If I can help, I like seeing other people succeed. So I like to dive in and dig my hands into different things. And some fun facts, you know, I have a podcast. I tell really bad math jokes. I might tell a couple of puns here today. And I enjoy a healthy appetite for burritos. But if you were here in the last Tuesday session for the GK Math and Praxis Math, let me know, how bad were my jokes on a scale of 1 to awful? Because I recognize some names here from the session on Tuesday. So let me know, how bad were those jokes? And while you guys type that in and let me know how bad my math jokes are so I can find some even worse ones, let's go ahead and go over the competencies and skills for the FTCE 612 math. And so those of us that are here and are in Praxis, do not worry at all, okay? Don't worry at all, because the thing is, the FTCE and Praxis 612 math cover the exact same topics. I'm talking like skill for skill, line for line, they are all the same. The only thing that is not on the Praxis is competency 10. And this is the knowledge of instruction and assessment. This is where you'll be answering questions regarding how to teach the math that you are doing. So it's a very different thing. This is a component that all SAE exams have for the FTCE, but not the Praxis content. They have a separate test for teaching it, but that is the only difference at all. So give yourself a shout out. Are you here for the FTCE or Praxis? Go ahead in the chat box. Are you here for FTCE or Praxis? Nice. Looks like it's a gang of FTCE folks. Looks like we may have forgotten about our Praxis folks and giving them love and spreading that word. So we'll make sure we'll get them in here and get them that recording. No problem at all. Wow. Everybody here's from FTCE. Nice. All right, guys. So let's go ahead and keep things simple. I'm going to teach you guys this one strategy, destination plan follow, and we're going to use it for every problem that we do. Because the thing is, in this test, there are 10 competencies. And if you notice, algebra, that's a whole class. Advanced algebra, algebra 2, another class. Geometry, that's another class. Coordinate geometry, same thing there. Trigonometry, statistics and probability, calculus, mathematical reasoning, an entire competency on just functions. Do you see how we are going through every single math class from 9th grade, algebra 1, geometry, algebra 2, pre-calculus, trigonometry, and calc 1? There's a lot here. There is a lot. And if you look at the percentages for everything, I mean, everything is pretty much related together. Like everything is pretty much around the same percentage. If you really had to avoid one topic, it'd be mathematical reasoning, 5% of your test. So that would essentially make up 2 questions. But that is that's pretty much it. So this is the only one that you can really ignore if you absolutely needed to, but everything else is on the same scale. And that proves to be a big challenge for us because we can't just rely on one competency to win it all. We have to be balanced in everything. So who here knew that? Who here knew that all of these courses were part of the 612 math? And who didn't? Give me a yes or no in the chat box. So it's not exactly half, but it is a fair split though. The majority are saying yes, but there are still a few people that say no. And that's our job here, everybody. We cannot beat an enemy that we don't know about. And so the first step is really immersing ourselves in understanding what we're in for. Because if we know what we're in for, we can prepare for it better. It's like, hey, dude, tomorrow you're going to fight a dragon. Oh, God. Or, hey, dude, tomorrow you're going to fight a dragon that if you just stare at it right in the eyes, it won't attack you. And if you say the words abracadabra, it goes away. Cool. If I know that going in, I won't be as nervous. But if I'm told that I'm going to fight a dragon tomorrow, I'm going to die. So yeah, no. And Kristen, to answer your questions, 75. There are approximately 75 multiple choice questions for the 612 math. All right. So with that said, again, we're going to keep things simple for this strategy, for this session here. Destination, plan, follow. Give me a yes or no in the chat box if you've heard this strategy before and if you like it or not. And if you haven't, just say no, because I'm going to go through it right now. Destination, plan, follow. So every question that you go through, you want to have a disciplined approach. Seriously, you need to have a disciplined approach because it takes away that anxiety, that nervousness, that jittery feeling. So the first thing you should do in every math problem is identify what the goal is. So what's the situation and what's the goal? Just understand the goal. Don't worry about the extra fluff, the extra information that you're going to need to write down or whatever it is. Just identify the general idea in terms of the story, not the math, just the story and what your goal is for the problem. If you have to talk about math, try to talk about the most recognizable math you can talk about. Just try to avoid anything you don't understand. That's it. As simple as that. First step, just analyze. The thing is, the majority of us, over 80% of us, tend to grab our calculators first. But think about it like this. A calculator is a tool. Now, we can think of other tools like our cars, power tools, a jackhammer, all of these different things that we use to get things done. And we tend to, with every tool in real life, think about why we need to pick this tool up to use it before we pick it up. And it's the same thing with a calculator. Guys, we cannot read through a word problem just to grab our calculator for the words and numbers that we see to get us nervous, just typing in those numbers into our calculator and just hoping for the best. We cannot do that. We have to first understand what's going on, like in every real world situation, and understand what the goal is. Because then we're going to plan things out using the information that we have to connect what we know to what we need to know. But again, cannot calculate yet. We just have to plan after that. Basically convincing ourselves that the math we're about to do is right. Think about building a building, constructing a building. First, they say, hey, we want a building. These are the specifications. We want 50 floors, this many doors, yada, yada, yada. Then we're going to make a blueprint for it. And then we're going to hire our men and actually build this building. Same thing in math. Take a moment to analyze the situation, identify your goal, connect what you have to where you need to get to with math, with logic, and then calculate. So everybody, can I get you to buy into that idea? The idea that we're not going to calculate first, that we're not even going to think about picking up our calculator until we understand what we might need to do. Give me a yes if you're all in. Right on. I'm glad we can buy in. And I'm going to help you practice this technique because if it's your first time using it, it's going to start off a little slow, and that's fine. But we're going to get this done the right way. So today's theme, we're going to give you a taste of our upcoming 612 Math Bootcamp. We're going to go through different problems from different skills. Obviously, there's no way I can get through all of them, not all 81 skills. So we're going to go through a sample of about 5 to 8 questions, whatever we can get to in this time. And then we're going to forward that over and we're going to send out some samples, every here and there until the release of our course. But just remember, you want to try your best. If you're not trying, you're not getting the experience you need. Yes, it's possible that you're going to be wrong. Absolutely possible. But remember, at the end of the day, if you don't try, you don't grow. Because if you don't try, you're forfeiting the opportunity to see where your mistakes can be. So here we go. Type hashtag when you pass if you're all in. Let's get it in. I'm going to give everybody 10 seconds to type in hashtag when you pass. Because that's our attitude. Remember, it is not if, but when. Because you will pass. You will. Follow our lead, get the right practice in, and you got this. So practice number 1. I'm going to give us actually 3 minutes per question here. Typically, you're going to get about 1 minute 35 seconds on the test itself, but I'm going to go ahead and give us 3 minutes here to just see if we can get these problems done at shock value, at seeing them for the first time. So 3 minutes, 3, 2, 1, go. Do not share your answer until I say ready, or until I say go. Guys, keep trying it out, try to find a way, you got this. Three, 2, 1, go. Provide your answer and let us know whether it was a guess or not. And if you just were completely lost the entire time, go ahead and say so. Go ahead and admit it, because I want to take you from where you are to where you can be. So just, yeah, be honest. Be honest. Were you lost? Did you get an answer? Did you take a guess? Be honest. So the majority of us are saying that we took a guess, that we feel lost. Hey, that's completely okay, guys. That's completely okay. This test is not difficult because of the concepts. It's difficult because it has a lot of different concepts, a lot of concepts that by themselves are very manageable, but altogether, it's going to take a lot of willpower to really get everything done together. So with that said, allow me to review the answer right now. What is the unit digit of 28 to the power of 13 minus 18? So I'm not going to reveal the answer. I'm going to work it out first. So here we go. First things first, we want to read the question. Everybody, what is it that we're trying to accomplish here? At the end of the day, what is it that we want? So destination, what is it that we want at the end of the day here? Yeah, we want the unit digit, right? We want the unit digit. And so I'm not going to patronize everybody here. We know what the unit digit is. If we had a number like 5,623, then the unit digit would be 3. Simple as that, right? The question is, what the heck does this all add up to or subtract to, right? That's the question. So did anybody here try to pick up their calculator and plug in 28 to the power of 13 and then subtract 18? Did anybody try to do that? I mean, yes or no, really quick. Okay, so a couple people did at first, okay, right? And you quickly found out that ain't happening, right? There's no possible way that that's happening. So with those of us that didn't do that, what did you try out? What did you try to do? Quickly. Let's try to type this out. What did we try to do? What did we try to do? Because the thing is, there's a key to problems like this. There really is. And I want to see if anybody noticed or even hinted at understanding what that hint is. You guessed that both had an 8. 28 times 13 minus 18 is 346. You used nothing, you just got lost, so you guessed. All right, cool. So then, all right, I'm gonna take us all from where we are to where we need to be. Here we go. Here's the first big key about problems like this. If the computation looks ridiculous, so a problem like this about number theory where they're asking you for the unit digit of some ridiculously big number, the hint is this. It's a massive number. So it's not about knowing what the number is, it's about recognizing a pattern. So if the problem looks like it'll take too much time, then there must be a pattern to get it done quicker. Then there must be a pattern. And here's what I mean, everybody. First off, let's start off with that 28 to the power of 13. Because think about it like this. If we knew what the unit digit was of this number, then if we're subtracting 18, we would just subtract the units, right? Then if we had to borrow a 1, we can borrow a 1. Yeah, that applies to every problem in math. If it looks like it'll take too much time doing it directly and manually, there must be a pattern that you can apply. So everybody, pay attention here. I'm going to show you this pattern. So first things first, 28 to the power of 13, everybody, what does that mean? Does that mean we're doing 28 times 13, or are we doing 28 times itself 13 times? Which one of those is it? Exactly. We're multiplying it by itself. So 28 times 28 times 28 times 28, 13 times. That's what that actually means. 28 to the power of 13 does not mean 28 times 13. So that's relief number 1. That is misconception number 1 about powers. Number 2 now, let's start recognizing some patterns. They only wanted what? The unit digit. So let me only go ahead and focus on the unit digit. But before I show you that, let me do it in a broad way. Everybody help me out. 28 to the power of 1, what is that? Right, anything to the power of 1 is itself, correct? Because you're multiplying something by itself, but just leaving it by itself one time, right? So it's 28. What about 28 squared? What if I went up and squared it? Grab your calculators. What do we get? 784. All right, cool. So 784. And remember, everybody, we're only concerned with the unit digit. So at first we had an 8, then we had a 4. So far, I don't see a pattern. But let's go ahead and move it up a notch. So let's multiply by another 28 and do 28 cubed. Remember, 28 squared means 28 times 28. 28 cubed means 28 times 28 times 28 again. So I have one person claiming that it's 21,952. Let's confirm that, everybody. All right, perfect. So we have 3 people that have confirmed it. So it's 21,952. All right, so we'll look at that. Still no pattern. So at this point, a lot of us may think, dang, this is not going to work out very well for me. I should give up. I don't know what the answer is. No, remember, if the problem looks like it'll take too much time, it has a pattern. Let's do it again. 28 to the power of 4, everybody. What's that going to give us? I know a lot of us are like, oh my God, this is huge. You're up 614, 656. Right. So boom, now we have 6. Still no pattern. Oh my gosh, right? No worries, guys. No worries, no worries. What's 28 to the power of 5? Multiply by another 28. What do we get? Whoo, that's a big number, right? I don't care about the actual number. I just care about the unit digit, which is an 8. What if I did 28 to the power of 6? What's the unit digit there? Don't worry about everything else. Just worry about the unit digit. Ah, look at that. Hey, everybody. Do we see a pattern now? Yeah, we see a pattern. We definitely do. And let me go ahead and show you this really quick. Notice how they asked us for the unit digit? Okay, look, we don't have to multiply the 28 to the power. We can just focus on the unit digit to the power. Because think about it like this. The part that's 20, it really will not matter at all. Because this is a 0 and the 2 is in the tens place. And you can only multiply up to the next digit. So that 2 will never affect the unit digit. It'll only affect the 10 digit and beyond, so the tens, hundreds, and thousands. Only the unit digit multiplications, additions, subtractions will affect the unit place. So let me prove that to you. Let's just keep it simple with 8. 8 to the power of 1. Quick, everybody, what is it? 8. 8 to the power of 2. What's that going to be? 16. Whoops, not 16. 64. 64. Remember, 8 times 8. Exactly, 8 times 8. 8 cubed, everybody. What's that going to be now? 512. All right, cool. And then lastly, 8 to the power of 4. What's that going to be? 4096. Okay, okay. Let's get a little crazier. 8 to the power of 5. What's that going to be? 32768. All right, so I'm going to stop right there. And I'm going to prove to you that only the unit digit matters here. I compared 8 versus 28 and their powers. Carefully follow along. 8, 4, 2, 6. 8, 4, 2, 6. And if you keep going again, 8, then it'll be 4, then it'll be 2, and then it'll be 6 again. Because 8 times 8 is 64. 4 times 8 is 32. 2 times 8 is 16. Everyone, what is the pattern that you just noticed for the powers of 8? Type it into the chat box. What do you think the pattern is? What do you think the pattern is? I like that, Kristen. 8, 4, 2, 6. And so is there any repetition with that? Yeah, Amanda, yeah, 8, 4, 2, 6. And then you repeat as many times as you need to. So everyone else, though, I know I may be going a little fast. So this is where it really is up to you. If you tell me I'm going too fast, I can double back real quick, real easy. Am I going too fast for anybody at all? Because this is a tough problem. Let me know if I'm going too fast for you. I am more than happy to go back. We all got it? All right, perfect. Sounds good. But just know really quick though, guys, for real, if you need me to pause and double back, I definitely will. Francis, thank you for saying that. So again, here's what we're trying to notice. The pattern here. We're just trying to notice the pattern because we don't know what the heck this number is going to be. We can't even write it out on our calculators. We just want the unit digit of that number. So we looked at the patterns. 8 to the power of 1, that's 8. Then the next power is a unit digit of 4, then 2, then 6, and it repeats every 4 numbers. So with that said, if I'm trying to find out what 28 to the power of 13 is, you can say that, hey, look, it repeats every 4. So that means that at 8 to the power of 8, that'll also be 6 as the unit digit. And if I keep going after that, that means 8 to the power of 12 is going to be 6 in the unit digit. Do you see how that makes sense? Since it repeats every 4, every 4th number will end in 6. And so then, if I want 8 to the power of 13, where do I go back to? Exactly, guys. Look at that. Yup. Now we're starting to pick up on this, right? It's a pattern. So boom. So we know that the unit digit of this massive number, it's gonna be some massive number with 8 at the end, and we're gonna subtract 18. So in that case, if we're subtracting a big number that ends in 8 and we're taking away 18, the unit digit, I don't care about the rest of the number, but the unit digit has to be what, everybody? That's right, my party people, 0. Because 8 minus 8 will be 0. And boom, it'll be some massive number with 0 at the end. Just like that. Just like that. So on a scale of no to yes, did I better your understanding of this specific problem here? And the number of S's that you use will tell me how much you understood it. Thanks, ladies. Appreciate it. Cassandra. Right, but also, of course, yes, because they're saying, hey, what's the unit digit of this number? So the hint for us is that, hey, just find the unit digits of those numbers and subtract them. The hard part was finding the unit digit of some obnoxiously large exponent. That was the tough part. And that's where the pattern recognition comes in. And that's why we just said, hey, I don't care to go all the way up to that number. Let me just see if I can notice a pattern with the units, not the rest of the number. So there's that, everybody. There's that. But notice how destination plan follow really does help here. In the beginning, even though this isn't a word problem, we literally looked at this and said, hey, I recognize the term unit digit, and I recognize that this is a subtraction. So I'm going to keep it simple and try to only find the unit digit of those numbers. That's going to take a more complicated approach to finding the pattern, which does take a little time. But if you persevere, we've seen the pattern, we can apply it and get our answer. A lot of us are going to be really concerned with writing this number out all the way through. And ladies and gentlemen, that's not the point of this. That's not the point of this. The point was simply to capture the unit digit. So Kristen says, is there a shortcut to know how long it takes for a unit digit to repeat? Kristen, the maximum it'll take is 4 iterations. I can tell you that right now. For any number from 0 to 9, the maximum number of iterations it always takes is 4. Like if you had powers of 5, that's a really easy one because it always stays 5. Think about it. 5 times 5 is 25. 25 times 5, 125. Yada, yada, yada. Things like ending in 1 always ends in 1 because 1 times 1 will always be 1. 2 will repeat every 4 because it goes 2, then 4, then 8, then 6, then 2, then 4, then 8. So think about it like this. If you practice these repetitions, a problem like this will be cake. And that's the good thing about this. All you have to know is pattern recognition with powers. And that takes a quick little 10, 15-minute drill just to see all of them. And you don't have to memorize them. You just have to know how to make it. So yeah, but also you still have to find the pattern, yeah. I didn't know what a unit digit meant, but now you know, and it's a lot easier. Bianca, I'm proud of that, for sure. So everybody, do we feel good about this problem? Ready for the next one? And yeah, but also we do have practices to exercise this, for sure, for sure. All right, so coming up next, problem number 2. Again, I'm gonna give us a little more time though, because I did realize, hey, maybe that first exposure maybe takes a little more time. So I'll give us 4 minutes this time. I'll give us 4 minutes. Remember, don't share your answer. Try this thing out alone, but try. Look for those little things. I'll try to maybe post a hint in the chat box. 3, 2, 1, go. Remember, type ready in the chat box. When you're ready, don't reveal your answer. Good stuff, Bianca. I see that you're ready. Go ahead now and just go through it again and convince yourself that you're right. So use that time to convince yourself. All right, we're looking at just about 45 seconds left. So again, if you're done early, just make sure you're going back in there and really soaking it in. Convince yourself that you're right. Convince yourself. All right, and 3, 2, 1, same thing. Share your answer. Let us know if it was a guess. Let us know if you were just crippled here and were lost. Let us know honestly. Go. So lost. Some are saying A, some are saying D, some are saying B, some are saying B. So it looks like we're all over the place here as well. And that's completely okay. That's why we're here. That's why this webinar is awesome, because you're going to see those little things, those little things that you can improve upon. So again, remember guys, this is not real test day. This is practice. So what that means is if you get a question wrong, it's not the end of the world. We should be happy to be wrong here so that we're not wrong on the test. So let's expose those little kinks now, right? So how many solutions does the equation above have? That's the question. All right, everybody, did they ask us to figure out what x is? No, they just want to know if this thing has a solution and how many solutions it has. Now, there's a reason nobody here chose C, and that's for a very good reason. There's this little thing called the fundamental theorem of algebra. I don't know if anybody here has heard of it. You probably have. Maybe it was just a quick little high and by in school. But here's what the fundamental theorem of algebra states. In an equation that has x squared, x cubed, whatever it may be, the maximum number of solutions, the maximum real number of solutions is equal to the degree of the equation. And the degree of the equation is the highest degree on any of the x's. So with that said, everybody, what degree do we see on this x if we don't see anything at all? Correct. We see a 1 there. It's an imaginary 1. And anytime you see a number or a variable without an exponent, yeah, it's an imaginary 1. So because of that, what's the maximum number of real solutions we can have then, everybody? Correct, 1. That's the fundamental theorem of algebra. The number of solutions you can have is equal to the highest degree. The number of solutions you can have, okay? So C would, without any doubt, be gone. Because again, this is a linear equation, not a quadratic or a polynomial. It's just a linear equation. So with that said, that doesn't do quite enough for us, right? That doesn't do quite enough for us. It looks like we may have to try to solve this to see how many solutions there are. So with that said, let's dive back in here and let's ask ourselves, what's the first thing we can do here? And give me a general thing, like simplify or move to the other side. Like simply put, what could we do at first? Yeah, I like that. All 4 of us move at the very beginning. Yeah, distribute. So simplify by distributing. Exactly. So let's go ahead and distribute this -2 here to both of these. And let's distribute that -3 to both of these. Remember, the distributive property, everything outside of the parentheses goes ahead and interacts or multiplies with everything inside. So with that said, let's go ahead and do it. -2 times x, everybody gather along quickly here. -2 times x gives us, booyah, -2x. Next, -2 times +3, go, 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 gives us a -6, a good eye. Many people would say +6. Good stuff there. So we're going to continue writing everything else out, just dropping everything else down. And then over here on the right side of the equal sign, -3 times x, everybody. What's that going to give us? Correct. Thank you for being attentive there. Then -3 multiplied by 4. What's that going to be? Correct. -12, a positive times a negative gives us a negative. Remember that. Up next, the 2 just drops down. Boom. So now that we have this giant mess so far, let's go ahead and fix this giant mess. So with that said, the next thing I'm going to keep my eye on is what? What should we do next in a general sense? I love it. You guys are really on this. Combine like terms. Yes. Combine these like terms. So let's do that. The like terms that I have on my left side, they're going to be -2x and -x. Again, what like terms are terms that have the same variable and the same powers. So if we had x squared plus, let's say, x to the power of 5, you can't add these because although they are the same variable, they're not the same power. And so these are not like terms. They would keep it as is, x squared plus x to the 5th. However, if we're taking a look at -2x and -x, that's like saying, hey, if I took away 2 apples and I took away another apple, I have taken away 3 apples. Just like that. So those are my like terms. And I'll continue on here to look at the -6 and the -4. If I take 6 away and I take 4 away, I end up at, exactly, taking away 10, -10. So boom. If I take a look at this right side, my -3x stays the same. So that's pretty good there. And already I'm looking at this like, okay. But what's -12 plus 2? So if I take away 12 and add 2 back, I am at, yes, -10. So what do we notice about the left and the right sides of this equation? They are the same. Yes, they are the same. So everybody, what does that mean the answer would be? What do you guys think it is? Is it none or infinitely many? Or is it 1? Which one is it? So far with what we have. Because some say any x, which is infinitely many. Some say none. All right, and one of us says 1. That's fine. Let's go ahead and take a look here. Let's dive back in here. Think about it like this, everybody. I'm going to just continue on to try to solve this and try to move things to the same side. Watch this. I want to add 3x to both sides to get rid of this -3x. Oh, look at that. What happens? This cancels and that cancels. So now I have -10 equals -10. Again, still the same thing on both sides. Everybody, let me ask you this. Does -10 always equal -10? Yeah, it absolutely does. If you put the number -10 next to the number -10 and never did anything else to it, yeah, -10 is always -10. And because it is always -10, equaling always -10, that means that, hey, look, it doesn't matter what you put in for the x. This equation will be true no matter what x you put in. So what that means is you have infinitely many solutions. And that's how I like to look at it. If I get in an equation when I'm simplifying the same thing on the left side as the right side, that means that you're going to have an infinitely many solution set. And that's because it doesn't matter what you put in for x. For example, let me just go back to that -3x plus 10 or minus 10 equals -3x minus 10. Guys, give me any random number. I can put in 5, right? I can put in 5. -3 times 5 minus 10. Will it be the same thing as -3 times 5 minus 10? Absolutely. Absolutely. Yes, it is a rule, but I'll say absolutely. Because again, -15 minus 10 is what you have on the left side. And on the right side is -15 minus 10, which will end up being -25 equals -25. So again, you get the same thing on both sides. No matter what you plug in for x, the equation is true. And because of that, you can select all the numbers, an infinitely many set of numbers. Does that make sense, everybody? How are we feeling about this? Do we feel better? And why do we feel better? Like, what is it that you didn't understand before that we understand now? I'll give us a couple of seconds. Where were we at before and what are we at now? And Amanda, I'm going to address you right now. Wouldn't infinitely many be eliminated as an answer? Because if the fundamental theme of algebra, I thought you said the max number of solutions we can have is 1. Oh, so here's the thing. Infinitely many, it's not exactly a number. Infinitely many is an approach. You're saying that this thing that is not bounded at all. So the term infinity, it's not a number. It's not 1, 2, 3, 4. It's literally just saying everything. And so in terms of the number of real solutions, Amanda, I'm saying that it has a maximum of real solutions of 1. All right. So for example, here's another example. Like, let me just use red here. If we're looking at the equation x squared plus, let's say 5x plus 6 equals whatever, 0. The thing here is, if we have a power of 2, that means the maximum number of real solutions that we can have is 2. That's what that would mean. So thank you for asking that question, because it's going to allow me to clear it up for you so you can understand it even more. So yeah, Yaslin, so if you got an equation similar to this, sure, go about it the same way. You can go ahead and try to solve it. And if you receive the same thing on the left and the right sides, boom, instantly, infinitely many. But everybody, what if you get an equation like this? What if you have 2x plus 5 equals 2x plus, let's say, 7? What if we had something like that? Well, let's go ahead and subtract the 2x from both sides, because it's going to reveal exactly what we should be looking at. So I'll use purple here. Minus 2x minus 2x. If I do that, I eliminate that on the left and right sides, allowing me to see that 5 equals what? Everybody, does 5 ever equal 7? Right? Absolutely not. Will 5 ever equal 7? Absolutely not. 5 will never be equal to 7. 5 is 5, 7 is 7. They are never equal to each other. So there are no solutions here. Do we see that, everybody? I'm literally giving you a mini live lesson on solution sets. This is awesome. I'm glad you got it, Yaslin. I'm glad you got it. Hey, no worries, Jennifer. I got your back. I got your back, girl. Whoop, whoop. So with that said, if you'd like to take a quick picture of this, please do. But remember, this will be on our YouTube channel. It will be on our YouTube channel. So get ready to, watch the recording again. Don't feel like you have to take every single bit of notes here. I really just want you to sit back, relax, and soak it all in. So with that said, so the answer, when would the answer be 1? Oh, for sure. So Gail, yeah. So if we're looking at an example like the following, like a regular everyday example, like 2x plus 1 equals 7. We can subtract 1 from both sides. Then we'll have 2x equals 6. And then we can just divide by 2 on both sides to get x equals 3. So how many numbers did we get for 3 or for x? We got one number. And so the solution would be there is one solution where x is equal to 3. So yeah, Gail, yeah, the answer would be 1 when it's just like a regular equation where you can actually get an answer for x. But in these two cases that we saw before, in the question that we have, we could never get a value for x, only that the left side and the right side are always equal. And then for the other example that we did over here, we saw a case where the two sides are never equal. And then your everyday solutions that we see in the GK math or the Praxis core math, yeah, they're usually solvable equations. But the thing about the 612 is that they are more advanced. They're looking at the nitty gritty, the actual fundamentals of mathematics, not just if you can follow a procedure or not. That's what makes the 612 a different animal than the GK. So did I answer all of our questions here regarding this question? Because I really do want to make sure that I hit everything home because we have a couple of more questions to go through. Yeah, I got it. Perfect, perfect, perfect. I'm just happy to help out. Seriously. I'm so happy to help out. All right. So we're going to start the next question here. Another topic, starting in 5. What also says, so is there a way to answer this question without working the problem out? Well, yeah, if you can do it mentally, like if you have it like that, sure, go ahead. But here, all you have to do is expand here and simplify. And as soon as you get to this step, seeing that negative 3x minus 10 equals negative 3x minus 10, boom. The left side is the same exact thing as the right side. No matter what you put in for x, it's true, infinitely many solutions, and you're done. So you may not have to go all the way down to this. If you can notice it here, you're good. So with that said, here we go. 5, 4, 3, 2, and 1. Keep it simple. Destination, plan, follow. This one, again, 4 minutes. This one's going to be even tougher. Or maybe not. Don't let me really throw you off. Just destination, plan, and follow. Analyze that thing. And remember to type ready when you're ready. All right, who would like more time? Because that is 4 minutes already. Who would like an extra minute? Who would like an extra minute? No one's typing, so I'm assuming everybody's still working. All right, I'll give it an extra 30 seconds here. I'll give it an extra 30. The hint is not that we can add the work together, but adding the reciprocals of the work together. So basically, the hint is you can't add the work together to get more time. You have to add them to get less time. So that means you need to invert the work that you're doing to add it together. That's the hint. And if that doesn't make sense, no worries. I'll explain it. All right, so just about 10 seconds here, and we're diving right in. 2, 1, time. What do we got? What do we got? Let's dive right in. Let's dive right in. What do we have? And if it's a guess, as always, again, just admit it. Just admit it. I'm just exposing you to the types of problems that you're going to see on the 612 math so I can show you exactly what you need to do to prepare. You're lost. You're guessing A. You're lost. C. It's a guess. Okay. Okay. Hey, thanks for being honest. As always, thanks for being honest. So let's dive in. Working together, 2 pumps can fill a particular pool in 3 hours. If it takes 1 pump 7 hours to fill the pool by itself, how long in hours will it take the other pump to fill the pool by itself? All right, everybody. So destination, this is where it's so important to not freak out. So important because we haven't done a word problem yet. Here we go. What is the essential basic like caveman talk? What are we talking about story-wise? Not math. I don't care about hours right now. I want to know what the story is about in caveman talk. Give me 3 words or less. What are we talking about in the story? Right, filling a pool. Okay, cool. We can imagine that. Ooh, I love that, Kristen. You're talking about right now. You're like, oh, nice. Yes, think about it. We are discussing a pool. Now, here's what we've got. What are we looking for regarding filling this pool? Let's be specific though. Time filling up for what? Like what, the pumps, like both pumps, 1 pump, like what are we discussing? What are we trying to find here? The hours for what? Right. How long it'll take the second pump to fill it by itself. Exactly. Exactly. So here's what we're going to do, everybody. Here's what we're going to do. Let me just show you how these work problems work. No pun intended. Pay attention. Just don't worry about taking notes right now. Just soak it in, then take notes. So the information that I'm going to write down. So this is where I'm starting to make my plan. I'm just going to write down the given information because the solution is not obvious yet. But the big hint, the big phrase here, working together. 2 things can do something in this amount of time. The key phrase here, working together, and they're talking about time or how much time it takes or how much work you get done. That is the biggest key to tell you that this is a work problem. When you hear working together, working alone, that is the biggest key that you're dealing with a problem like this. And here's how you get it done. I'm going to highlight everything else here. 1 pump 7 hours by itself. How long will it take the other pump to fill by itself? So let's just write that out. We want blank hours for the second pump. We know that the first pump takes 7 hours by itself. And again, you won't be writing all of this out. You won't be writing all of this out. I'm just literally laying it all out for us. 7 hours right there. All right. And then lastly, together, it takes 3 hours to work together. All right. So think about it like this, everybody. If you think that you can add these together, so I'm going to say T hours here for the second pump, if that's okay with everybody. But think about it like this. If I'm saying if it takes T hours for the second pump to get that job done, so T hours per filling the pool, and let me change that to black actually. So if it takes T hours to fill the pool, and I add that to 7 hours for the other pump, again, it takes 7 hours to fill that one pool, so 7 hours per pool. I'm just trying to make this make sense in English first. If that's supposed to equal 3 hours, why is it that if you add hours up, especially with 7 here, you go down to 3? Everybody, is this a direct relationship or is this an inverted relationship? And if you want to guess on that, take a guess. But is this a direct or inverted relationship? And even if you don't know what inverted means, take a guess. Yeah, and we're correct right now. Yeah, it's an inverted relationship. And here's what I mean by inverted. So this is the key for these work problems. Even if you don't understand the concept, you will understand the units behind it. So we're not saying that we want to add these times together. That's not what we're doing, because if you add hours together, there's no way that you can get less hours. So that's hinting at me that we're writing the units wrong. We're writing them wrong. Here's how we should actually write them. So instead of saying it's T hours for per the whole pool, essentially I'm going to flip it. I'm going to say 1 over T, because if I flip it, I'm saying that you get 1 over T of the pool done per hour. And this probably doesn't make a lot of sense, right? Let me just show you the 7 now. If it takes you 7 hours to fill a pool, what fraction of the pool do you get done in 1 hour? So instead of hours per pool, if we flip it to pool per hours, or pool, the amount of the pool per hour, think about it. If it takes you 7 hours to do it, in 1 hour, how much of the job do you get done? If it's 7 hours, in 1 of those 7 hours, how much work is it? 1 out of 7 of the work. Yeah, 1/7 of the work. And again, all I did was I flipped the units. So when you flip the unit, you gotta flip the actual number itself. You have to take the reciprocal of it. Because again, this first equation was written incorrectly from the get-go. We're actually needing to write the inverse relationship. Because if you say, hey, I get this much work done in 1 hour with that pump by itself, plus this much work in 1 hour with that pump by itself, together, everybody, if it takes them 3 hours together, in 1 hour, how much of that work do they get done together? Kristen, you're turning into a superstar here. Yes, if it takes them 3 hours to get the work done together, in 1 hour, they will have accomplished 1 out of the 3 hours worth of work. So in 1 hour, they can get 1/3 of the work done per hour, or 1/3 of the pool done every hour. So even if we're struggling to understand the inverted relationship, because this is a lesson that I would have to literally outline and teach for 30 to 45 minutes, but I'm just trying to help you point out the unit part of it, not the invert part of it. Don't worry about that right now. But do we see how I'm talking about it? Do we see that I'm saying, hey, look, if alone this gets 1 out of the total hours it takes by itself, and the other pump is 1/7 of the work done in every hour. That should be equal to the amount of work they get done together per hour, which is 1/3 of the job every hour. Because again, it takes 3 hours together. So in 1 hour, it takes they complete 1 out of 3 hours of work. By itself, in 1 hour, that second pump, or that first pump, again, alone 7 hours. So in 1 hour, it'll be 1 out of the 7 pieces of work to be done, or 1/7 of the pool. And if we knew what this was, what that T was, 3 hours, 5 hours, 9 hours, 12 hours, it would be 1 out of that per hour, no matter what. Do we see that, everybody? That's the only thing I want you to see. Everything else, don't worry about that right now. Just that piece. And be honest and say no if not. I understand that this is a very hard concept to teach a wide range of skills here, because I know some of us may be coming here with more experience than others. So be honest. Yes or no? Are we good with that piece? Jesse, cool. Jennifer, yes. Francis, yes. Basak, not quite. Okay, that's fine. Perfect. Esther, Gail, say yes. Ariel, not quite yet. Cassandra, yes. Amanda, no. All right. So what I want you to do before we continue, just mark that this is a word problem involving work. You can look up a lot more of these in between now and the time that we release this course. In this case, think fraction. Yes, Jesse. Yes, yes, yes. But here we go. I'm going to translate this and get rid of all those units now. We have 1 out of T, or 1 over T of work done in every hour for the first pump, 1/7 of the work done per hour for the second pump. Together, they get 1/3 of the work done in 1 hour. All right. Looks like we got to solve this thing. But everybody, what's the big problem here? Why can't we just add these fractions? Why is it that we can't add these fractions? Right, we need common denominators. So between these two, do they have a common factor? Do T and 7 share a common factor? Yeah, they absolutely do not, actually. 7 and 3 do. 7 and 3 do, absolutely. But T and 7 do not. T and 7 do not. So in order to combine only these guys, I'm not worrying about the 1/3. Don't worry about that. That's on the right side of the equal sign. We can leave it where it is. We can focus on just these two. But let's say that we don't like dealing with variables. Here's what you can also do. I can subtract 1/7 from both sides. I can do that instead, because what that's going to turn into, it cancels that out, leaving my variable by itself on the left, and then having 1/3 minus 1/7. This is actually a lot less stressful because you're dealing with whole numbers, not variables. So everybody, between 3 and 7 now, what's the common denominator between 3 and 7? Right, that's a lot easier, right? We can relieve, we can sigh a relief for that, for sure, right? So let's go ahead then and implement here. If I need the common denominator to be 21, everyone, what should I multiply 3 by to get 21? Correct, everybody. So what I'm going to do is I'm going to multiply the numerator and denominator by 7, because remember, whatever you do to the numerator, you have to do to the denominator, because you have to preserve the value of the number. 1 out of 3 and 7 out of 21 are the same number. They just look different. Okay. Now, what about the 1/7? What do I multiply the 1/7 by to get to 21? Absolutely. We get 3 there, because 1 times 3 doesn't matter as much as the 7 times 3 does, because now we're going to have common denominators. That's what we want. So let's rewrite it up here. 1 over T equals 7 over 21, because 1 times 7 is 7. And then 3 times 7, 21. Now over here, 1 times 3 gives us 3. And again, 7 times 3 gives us 21. So we essentially have 1 over T equals 7 over 21 minus 3 over 21. And if we continue going here, we'll have 1 over T equals what, everybody? Kristen says 4 over 21. So does Gail. Looks like we might have a consensus. Who agrees with that? It can't just be a two-person show. There we go. Yep. 4 out of 21. Because again, you leave the denominator the same and you simply subtract the numerators. So now we have 4 over 21. So 1 over t equals 4 over 21. There's 2 ways we can go about this. Yes or no, everybody? Could we cross multiply and divide here to get this done? Could we cross multiply and divide? We could, right? We definitely could, for sure. Here's something that not a lot of people know as well. You can cross multiply. Let me actually show that right now. So I'm going to go 2 methods here. One, I'm going to cross multiply and then divide. So cross multiplying. T times 4 is 4t. 1 times 21 equals 21. And then I divide by 4. And then I receive t equals what, everybody? Right, 5.25. 5.25 what again? Because t was measured in, hours. So it would take 5.25 hours for that other pump to get it by itself. But let me go back and revisit this, the other way that we can solve this, because we all know cross multiplying and dividing. We've seen proportions, but we can also just flip both sides. Literally, if each side is just one fraction, then flip them. 1 over t, flip it to t over 1. 4 over 21, flip it to 21 over 4. T divided by 1, that's just t. Just grab your calculator for 21 over 4, and that gives us what? The same thing. The same exact 5.25. So who didn't know that? That if we have a fraction equaling another fraction, we can literally just flip it if we need to. Give me a yes or no. Did you know that? I want to really know if we did. Yeah, Jen, you did? And even if you did know, did you have the complete wits about us to really recognize it at first, right? Instantly. So that's the thing. How we build up with our math skills, it's first you need to recognize the topic in terms of what it's about, what you need to do when you see certain things, how to recognize the situation you're in. Then it's about getting problems correct. And after that, you're working for speed. But you should not be working for speed if you don't have the concept down yet. How often does it happen to us, especially with math, we're getting nervous preparing for a test, and we're thinking that we just have to cover 5 topics every day for an hour apiece, all the way until test day. No. Guys, we actually have to start small with what we get and expand and expand and expand. If the first step in your study is literally tossing yourself to the wolves, you're going to get pretty discouraged pretty quick. I think that's pretty intuitive in terms of, again, trying to do something new. But if we take it slow, start from where we are and point and set a goal and say, hey, today I want to understand work word problems. Boom, sit your butt down and only work on that, because at the end of the day, you'll be able to talk about that a little better and make a little progress, as opposed to doing 5 different topics on the same day at the same time and not getting any of it by the end of the session. Has it ever happened to anybody where you're just trying to do different things on the same day and then none of it actually sticks? That happens, right? You have to go with one topic at a time. You have to, especially with a test like this. So what we've done, everybody, and we're not going to get to that last problem that we've got going on. If you want to take a screenshot of it, feel free. So go ahead, take a screenshot of this problem here if you would like to. I'll count down from 10, but no worries. It's going to be on YouTube anyway. Just want to see that you guys get the problem yourselves, though. Moving on right here to the next question. Take a screenshot of this too if you would like to. Go ahead, have your phone out. You're going to need to keep it out anyway. Go ahead, take a picture of this problem too. All right, 3, 2, and 1. So with that said, everybody, one last time though, destination, plan, follow. You always want to read the situation first. Seriously, guys, don't go head over heels trying to calculate what you don't know you need to calculate. Destination. And then we want to plan our solution. We want to plan our solution so that we can be confident about the steps we're going to take, just like constructing a building. We want the building, specifications, here's the blueprint, and then we're going to call the boys in and we're going to construct this thing. We're not going to bring all the men in and all the women in to construct a building that we don't have a plan for yet. No, that's the easiest way to either get sued or go to jail because you killed somebody. So with that said, it's a lot, this math is a lot easier than building a building. Yeah. So, but let's apply the same discipline to make it feel even easier. So with that said, everybody, how'd you feel? How'd you feel about this session? Did I do any sort of a good job in terms of either exposing you to the math, even if it costs you crying about it? Because again, this was tough math. Or, are we feeling like this just wasn't worth it at all? We're feeling pretty good. Again, I don't care about the job I did. I want to know how you feel after this. I want to know how you feel after this. Like, do you feel more confident about the direction that you need to take moving forward? Because we still haven't even gone over half the quarter or even a tenth of the topics, but I do want to give you direction moving forward. That's what this is about. Perfect. I'm glad that you guys got a lot of help out of this, because the thing is, guys, look, we've always put you first, even through this coronavirus deal. And so we know you can pass. You will pass with our plan. So we got two really cool things for you guys. A really cool thing. We have our upcoming course for this coming up. And guess what? We got over 150 questions in the first release. And in the second release, we're going to add 2 practice tests to it with video solutions. Oh, and all the problems that are already going to be in there, they're going to have video solutions too. That way, you can go ahead and take it nice and slow at your pace, going through the problems, and not some study guide where you're doing complex math, having to read through solutions that you still don't understand. No, I am going to provide you with a way to pass this test in the most pain-free way possible, avoiding those headaches, because you have access to me as an instructor that you can communicate with on the website. Is anybody here a current customer of ours in terms of any of the boot camps at all? Yeah. And so you see that discussion tab, you're in that Facebook group, you have access to us all day, every day. You can always email us, because that's the Learning Liaisons way. We will always put the teacher in as the first thing in every decision we make. We want you guys to be in the classroom, because that means the kids will be too. So with that said, again, our 612 math course is on pre-sale. It's going to be released May 10th. And if you grab your phone and scan this QR code, or do the lengthy process of copying that link down, hey, either way, you can get it on pre-sale right now, and you can use that stay-at-home code to get an even bigger discount. Because right now it's only $50 for the pre-release. It will be a lot more than that, trust me, once it's released. So with that said, you're going to want to take advantage of this. If you have any aspirations to pass this test, you're going to need this course, plain and simple. I have over 150 questions. They're going to be organized into drill sets. I go through every concept, and in the video solutions, I go through every concept therein and what you can do to better yourself in it. And then after about a month or two so after this is released, we're going to add in 2 practice tests at no additional cost to you. 2 full-length practice tests, 75 questions with video solutions, just like that. But again, you won't have to pay an extra dime at all if you buy it today. So this thing is going to be worth over $150, but you can get it today for $25 if you just use the stay-at-home code. So does anybody here think that that'll benefit them? Because I think it might. How are you feeling about it? Is this something that would benefit you? Jesse thinks it's cool. So the problems that we did today, so they fell under competencies 1, 2, and 3. So the algebra part, the advanced algebra, and then taking a little peek at that geometry. So it says it's closed online. I just checked it right before we began. Let me just double check for us right now. Let me just double check right here. Let's see if that's true, or if maybe we had one little hiccup that we can fix. All right. So I opened it up and I will hit enroll. And I have to sign in. All right. Do we have resources for the 5-9 math? We absolutely do. It's the 5-9 math. Yeah, we have a practice test out for it. And actually, right after I'm done with the 612, I will be making another bootcamp drill set course for the 5-9. So that's absolutely the next thing on my plate. But we do already have a practice test out for it.
Hey, Anderson, I think they said it was closed because they went to the old version that we shut down. So I'll exchange. They didn't use the link on the screen. I'll exchange that link to go to the new version.
Gotcha. So if they actually scan that QR code right there, that is actually it'll take them to the one we're talking about right now. So go ahead, guys, use your phones, open up your camera and scan that thing right there and you'll see it. It'll say SAE Mathematics 612 coming soon, May 10th, 2020. And Bianca, webinars for the 5-9? Because we actually haven't hosted a 5-9 webinar, but we absolutely can, Dr. A. Let's go ahead and mark that down. Let's have one for the 5-9. As we build that course and we get closer to releasing it, yeah, for sure, we'll definitely run a 5-9 webinar. But yeah, guys, with that said, I'll come back to this slide here. I will come back to this slide because the thing is, even if you have to take other courses or other tests like your GK, your SAE, your professional ed, your Feely, everything is still 50% off. We understand that this is not a normal situation. We understand that very well. But the thing is, at the end of the day, you need to pass and we have the resources to get you there. Again, everything's video based. You do have text documents that you can download as well. You have all the practice that you need through all of our courses to make sure that you pass. It's as simple as that. Again, until May 1st, if you use the coupon code STAY AT HOME, all caps, one word, you're good. And again, this applies to our bundles. So you can get half of our bundles that are already discounted heavily. You can get everything you need. If you get the VIP access, the VIP bundle, it's going to include the 612 math course. And absolutely, Bianca, we do have subtest resources for the K6. We absolutely do. Oh, and good news. So Dr. A, if you're still here, go ahead and chime in on this. But what I've realized is that a lot of the problems, and I'm talking over 90% of the problems that I've made for the Praxis elementary math actually are covered in the K6 math. So if I wanted to, within the next week, we could have a lot of problems uploaded into that K6 bootcamp course that we have, even though we already have a bunch. But we could add a ton more automatically. So Dr. A, let me know what you think about that.
Yeah, sure. I could always add problems into the course.
Cool. It looks like we're on the same page there. So if you're in K6, yeah, we're going to be adding a lot more videos and problems there within the next week. Booyah, Cassandra. Sounds good. Sounds good, girl. Once this thing comes out, you're going to be like, oh my God, this is the best $25 I've ever spent in my life. That's the goal for me.
So remember, guys, you use that code to secure that new course that Anderson's talking about for his 6 through 12. Just keep in mind that there's nothing in there right now. So don't look for I saw someone asked the question or said there's nothing there. There's nothing going to be in the course. Now, what happens is when Anderson finishes filming all the problems and putting them in there and organizing, they'll be in there for you. And we'll send you an email a day or two beforehand just to remind you, and obviously the day of, if you enroll in that. All right, so the course, like he mentioned, we have it priced on the website. It's $50 to give you half off with that code. It'll be just $25. And once Anderson adds his 150 problems to it, and then a month later another 150, then the price is going to go up, obviously. There's going to be no need for any study guides or anything with this course. He's going to teach you everything you need to know to pass this exam on the first try. So just that quick heads up, if you do, which I hope you take advantage of this ridiculous low price of $25 to secure your spot in that course, just know that there's nothing in there right now. It's going to be empty, but it'll be in your Learning Liaisons website, holding there for you until we fill it. Now, it is set for 2-month access, so we know that it's going to be May 10th. So what we're going to do is anyone who takes advantage of this and signs up beforehand, we will extend that for you. So obviously, we're not going to let it sit in your account for 3 weeks and then all of a sudden it's gone in another month. We'll restart it for you. We just want to give you guys the opportunity for attending here, for being able to jump on that at a really, really low price to save some money.
Booyah. Exactly. That's what it's all about, man. So for $25, you're going to get potential access to 300 problems. I think that is the biggest deal we could ever have given to you guys ever. So we're happy about that. We really are. Basak, right on. Perfect, perfect, perfect. I'm glad that I can, really expose you to this, man, for real. Because Basak, I remember you from other webinar sessions as well, man. I'm glad I can help. I am so happy I can help. Hey, no worries, Nicole. No worries at all. So with that said, guys, again, like I said, I'm respecting your time. We're getting out of here at 4:30. So I'm going to be here for the next 4 minutes to answer any and all questions that you may potentially have. Any and all. Does this work for the essay? The code stay at home? It absolutely does. It absolutely does, Ariel. So you want to go ahead and when you sign up, type in the coupon where it says redeem coupon. Boom, stay at home, all caps, hit redeem, and you're good. Hey, GB, for sure. You're welcome. You're absolutely welcome. You have yourself a great day too. Yeah, Gail. Oh, man. Making you love math. That's what I live for. Those are the moments. Seriously, it's these kind of moments that I wake up for every day because I know that my work at the end of the day makes other people happier. And that's why it's so fulfilling. Hey, you're welcome, Jesse. You have a good one, okay? Hey, Yaslin, you too. If you have any questions, remember, you can always reach out to me. I'm going to write my email. I'm going to type my email out here. If you have any questions at all, any at all that I can help you out with, feel free to reach out to me at anderson@thelearningliaisons.com. Can I share the answers to 4 and 5 this weekend? I actually won't be in town this weekend. I actually am going to be somewhere else. But if you email me and annoy me about this, like seriously, like I use the word annoy, not in the sense of you're actually annoying me, but just be persistent, like persist on me. And because the thing is I have so much going on, but if you constantly remind me, oh girl, I will put you first. If you are serious, like, oh man, get this done, get this done, get this done. I got you. I will get it done. Just annoy me. I'll get it done. I'm looking online, but it only shows the K6 is bundled. Oh, you can get the well, so which bundle are you looking for, Bianca? Are you looking to bundle your GK, SAE, and ProEd? And while Bianca answers that, Wilmar says, when will the 5-9 math course be ready to purchase? We're looking at early to midsummer, because once this gets done, I'm definitely going to need to take a week or two just to kind of like let my brain explode because I just made 300 problems here, and then I'm going to work on the 5-9. So yeah, right after I make sure my mental health is good, I'm going to come right back and work on the 5-9.
There is a 5 through 9 course on there. Anderson has one on the website. He's just going to update it and add a lot more new problems.
Yeah. So there's a practice test already there, yeah. And then I'm going to add to that practice test course with an additional, I want to say anywhere between 80 and 120 problems, I want to say.
Bianca, to answer your question, I would suggest you get the K through 6 video course that covers the social science and science. So Bianca, do you need the GK, the K through 6, and then also your professional ed?
And I'm just looking back here. So K Parker, peace and brother, thanks. Keep doing your thing. Okay, appreciate that for sure. Cassandra, just the answer, not the explanation. Okay, cool, sounds good. So at the end of this, before I shut the room down, I'm gonna go back up and just work them out really quick in my head. I'll do that in a moment. Yeah, Gail, you stay safe too, for real. Be safe, be safe. Bianca just needs, okay, perfect. Jennifer just says you just need the 612 and the 5-9. So cool. Jennifer, just go ahead, get each individually. Those are not available for bundle. So all you have to do is get them individually. So take advantage of that deal right now for sure. You did not get any email, should you? In terms of after signing up? Not yet, because we haven't set up everything yet in terms of that confirmation email and all that. We're gonna go ahead and work on that for you though. I got you, Basak. Yeah, no worries, Jennifer. No worries at all. So let me just go right back up here to really work on that question for us really quick for questions 4 and 5. To determine the measure of each exterior angle of a regular octagon, the answer here will be B45. Yep, B45. And then the other one, Cassandra, for number 5, what is the value of D, the distance between the shown coordinates? That's going to be A, the square root of 34. Let me see. 9 and 5, 34. Yep, square root of 34. So Cassandra, we have B, then A. B, then A. Okay, Cassandra, for 4 and 5, it's B, then A. Yeah, you're welcome. Anytime. Anytime. And so Cassandra, if you want to write this down as well, if you're still here, For number 4, you're just like, okay, so for Cassandra, so number 4, that is about the exterior angles of a polygon. So the exterior angle theorem of a polygon. And number 5 was about the distance formula or the Pythagorean theorem, whichever one you want to call it. But it's about the distance formula between points on the coordinate plane. And number 4 was about the exterior angle theorem. Eliana says the general knowledge is the video somewhere I can see it. The class was full and I couldn't. Yesterday's webinar, Dr. A. When will that recording be available for the webinar yesterday or Tuesday?
I put on YouTube this morning.
Oh, YouTube this morning. So, everybody, whoever's still here, remember, you gotta go ahead and subscribe to our YouTube page. You gotta do it. You gotta do it. If you want freebies, free videos, free advice, who the heck doesn't want that? Especially when you see what we can do in these webinars, right? So go ahead, grab your phone out again, scan that, or just go to youtube.com/thelearningliaisons, or go to the app and look up the Learning Liaisons. Either way, you'll find us there. Click subscribe, and boom, you're gonna get access to everything. Yeah, no worries, Eliana. No worries. Right on, right on. Looks like we are all good. So I will wait an additional minute to answer any and all questions that anybody has. But with that said, guys, it's Thursday. It's practically, one more day till Friday. So it's already the weekend for us. So that's how we do it here at the Learning Liaisons, making sure you're taken care of, making sure you have insight moving forward. Seriously, that's what it's all about. All right, we got 2 new messages. Sorry, I just had to pump up my own ego by going ahead and just Instagram storing a lot of these comments. Seriously, you guys are really kind for what you're saying, but I'm just so glad you guys got the help that you need. So with that said, guys, moving forward, just make sure you're preparing the right way, asking the right questions, and reaching out to me whenever you need me. With that said, remember that it's when you pass, not if you pass. We're the Learning Liaisons, and we'll see you next time.
When you pass, not if you pass.